Hey everybody, welcome to our beginning Python and GPIO tutorial using our Raspberry Pi 3. This particular version of this video is for Marygrove College EDT 623. So the first part of this video is going to be creating a new file. So we're going to go to the programming menu and select our Python 3 idle, which is the development environment where we are going to create our Python files. After you open your idle, you're going to go up to the file menu, which is in the top left of that window, and you're going to go ahead and select new file, and that will open your new file. So the next part is then to generate our code. So what we're going to do is we're going to start writing our code here, but first always we're going to save our file. And for this particular one, I think I called it GPIO test, and then as with all of our stuff, we'll put our last name under it. Please be careful, you cannot use a dash with Python. It has to be the underscore, which is the shift and the dash. So part one is we're going to use our imports. We're going to do two imports, which is rpy.gpio as GPIO. So this is going to actually be an object we refer back to. And then we're also going to import time. Imports are code library files. They're going to add a little bit of extra functionality to our program and allow us to do what we need to do. So in Python, unlike some of the other languages, you can use that pound sign or the hashtag as to do comments, and I've tried to comment some throughout the course of this. So after this, we're going to set up our board. So we're going to refer back to our GPIO object, to gpio.setup, or set mode rather, and we're going to use gpio.bcm. We're almost always going to use that because we have the adapter to plug into the breadboard. And we're going to go ahead and set warnings to false, so Python doesn't try and warn us about a whole bunch of different things as we go. I found that to be annoying, so we'll just turn it off. And variables. This is going to happen a lot like Arduino code, where we declare a variable where we refer to the pin to make it easier. In this particular case, we're going to be using pin 17. So after we have gone ahead and declared our variable, the next part we're going to do is going to be similar to what we would see with our setup loop with Arduino. And we're going to go ahead and, you don't have a setup loop in Python. We're going to do the same thing that you would do here, just as part of your normal code. So gpio.setup, we're going to set our LED pin variable to be an output pin. And we do that by doing LED pin, comma, gpio.out. As you go through here, capitalization is extraordinarily important. If you do not capitalize properly, it will not work, and you really don't want that. Bugs are bad. So we've gone ahead and we set up our pin 17, our LED pin, as an output pin, and now we're going to go ahead and we're going to test it. This I've found to be a really good wiring test, really. So what we're going to do is we're going to set our LED pin, gpio.output. We're going to go LED pin to 1. 1 is a true value. 1 turns the light on. And as opposed to the Arduino code, we're going to go ahead and do time.sleep. You would use delay in Arduino. Time.sleep is what you would use here. Also note, Arduino, you use time in milliseconds, so this value in Arduino would be 2000. In Python, you do not do that. For this particular one, it's in seconds, so you use 2. Please don't use 2000. I don't want to sit and wait for your stuff to happen 2000 seconds later. Thank you. So next one, same thing. We've turned the light on for 2 seconds. We are going to go ahead and we're going to turn the light off for 2 seconds by setting our GPIO.output to 0. Turns our light off. And then the same thing, we're going to build in 2 seconds worth of sleep. Now this last part here is cleanup. With Python, if you were to set the output to 1, it would just kind of stay there forever, and your program be over, the light would stay on. So when you say GPIO.cleanup, the cleanup will clear out all those commands that you did so you can use the board fresh for next time. And as always, save your file. So next up is board wiring. You can see the adapter there. You can see it hooked up to pin number 17. And then we have our LED and our resistor going to our ground rail. This is pretty standard, slightly different than Arduino, but pretty much the same way. So you can see there where that pin number 17 is, my little red arrow is pointing to the value there. And this is me actually doing it real time. You're going to have to excuse my hands here. I've been doing a little bit of yard work outside and they're a little gross, so my apologies. But I've plugged a wire into pin number 17. Now for this one, you're going to want to make sure that the longer LED leg goes towards that adapter. It's a little bit more user-friendly when you wire it that way. The longer one connects to the plus, remember. So we're going to connect the 17 board to the positive, to the longer rail. And we're going to connect our resistor to the shorter, to the minus rail. And then we're going to put it to the minus rail of the board as well. Just like that. So the moment of truth, does the code work? We're going to go ahead and run our code. We're going to go ahead and up to the run menu and do run module. You can also do F5. Now you'll see in this case, I've actually made a mistake. So the next step we're going to go ahead and go through is we're going to debug our code. Whenever you get that red error message, that means you have an error. In this particular case, the error is pretty simple, and Python actually tells you exactly what the error is. It tells you on line 6, it does not understand GPIO.set warnings to false. It says false is not defined. Well, as I mentioned to you a little bit earlier, capitalization is important. So if you go ahead and backspace and put a capital F, you'll notice it turns orange. Python is happy. Life is good. And we're going to go ahead and try running our code one more time. See if that fixed our problem. Go ahead and spoil it. It actually did fix our problem. So when we do F5 and run our module, you'll see that you don't have any error messages that occur. And if you've done everything right, your light goes on for 2 and off for 2 seconds.